Hey, what's up? What's up? What's up? मेरी आवाज साफ आ रही है? Yeah? You recognize this nice icon over here? ये क्या है? What's happening here? This is what we'll end this session with. Yeah? This is a transition state of the E2 mechanism. Good evening. Hi, hi, hi. You should be able to see me right about now. What's up? Hello. Good evening. How's this? Wait, what day is it? Thursday. How's this awesome Thursday evening treating you? Awaaz saaf aa rahi hai, you're able to see me clearly. All that's good. Yeah. Should we get started right away? There are a couple of homework questions. Mayuk answered them. We'll look at them. Mohammad Adil, Sandhya, Deepu, Deepanvita, good evening. Hey, hey. Neat, neat, neat. Yeah, neat is what we are at. Okay. First question tha from the last session homework. We'll get right into it. Arene diazonium salt results from reaction of nitrous acid with what? Mayuk said C. Do you guys agree with him or what? Oh, this also had to do with what? Yeah, the arene diazonium salt. ये कहाँ से आया? HNO2. I think it had something to do with Sandmeyer reaction, right? शायद, maybe. What's up, Sandhya? Welcome. Muhammad Adil is saying yes. So it looks like this one should be a primary aromatic arene. Amine, sorry. That's how the whole thing goes. Yeah, it may seem a little random to you. Yeah, Sandmeyer reaction was done 2 sessions back, and you're still asking questions on it. Yeah, because it comes in NEET. Okay, ठीक है. Anyway, this is the answer for that one. Revise the other sessions अगर ये याद नहीं है तो. Which is the following is an ambident nucleophile? My question said A was the answer of this one. And yeah, I think see ambident means that the charge or the electrons, the free electrons, lone pair of electrons available on two different atoms, and yeah, it can shift around. Now in this case, OH is definitely not it. Cl mein to ek hi hai, right? So the second atom is not there. So it must be NO2 minus, and Mayuk is absolutely right. Yeah, because of conjugation, it can go the electrons can go from nitrogen or from oxygen, from both of them. Okay, bro, Sandhya, good to know. What is step after? What is the step after the scene? The oh, अच्छा एक बार आपने टॉपिक देख लिया एनसीईआरटी के सारे सवाल करिए दैट्स इट दीपान्विता गुड जॉब एब्सोल्युटली ए इज आंसर या थैंक्स तनु हे व्हाट्स अप मोहम्मद आदिल जी बहुत अच्छा सवाल है आफ्टर यू वॉच हिज लेक्चर्स द बेस्ट थिंग टू डू इज सॉल्व एवरी क्वेश्चन इन एनसीईआरटी एंड यू आर सेट दैट्स ऑल यू नीड फॉर नीट लिटरली एक एक सवाल जो एनसीईआरटी के एंड में है उसको सॉल्व करिए एंड रीड द बुक मेक योर ओन नोट्स या आई एम गिविंग यू दीज नोट्स दीज आर अ रिच फॉर्मेट एंड help you remembering things and all that. But the main thing is you need to go through NCERT. Yeah, that's your best bet, Mohammad Adil ji. It's a good question. It's a good question. इसके साथ और क्या करें to get a good score in NEET? Yeah, absolutely. Now let's start with this session. The session begins here. Which of the following can be used as a solvent in SN2 reactions? SN2 reactions. Remember, SN2 reactions में था from last session. Polar aprotic solvent. Why polar aprotic solvent? क्योंकि aprotic solvent will not really solvent the nucleophile very well. So मतलब nucleophile is free to attack. Okay, and the only one that is polar and aprotic. Aprotic means no H, right? Protic, proton, is which one? कौन सा वाला? Good evening. What's up, Bisujit? Deepanand is saying A. Tanu was saying A. इस वाले में और कुछ पिछला नहीं बोल रहे थे. मोहम्मद आदिल is saying A here. इसमें H नहीं होना चाहिए. The only one that does not have H is this last chap over here. Okay. बाकी सब में H है. Ammonia obviously has H. Ethanol has H. I mean, I don't have to tell you all of this, right? So this is the answer to this one. You may not have seen this solvent, but that's all right. That's all right. Answer तो यही है for sure. So this is the thing, right? Even if something scary comes by elimination, you should be able to solve it. NEET especially सिर्फ NCERT से पूछेगा. But अगर by off chance कुछ अलग अजीब सा ऐसा दे दे, you still will be able to solve it with this idea. All right, cool. Couple of more questions. Arrange these compounds in order of reactivity towards SN2 reactions. Yeah, हम लोग SN2 रिवाइज करेंगे तभी तो SN1 करेंगे. 1 bromo 3 methyl butane 2 bromo इसका स्ट्रक्चर बनाना पड़ेगा मुझे लग रहा है. I'll do that. I'll help you draw the structure. आदिल जी, how? देखो polar aprotic solvent. Okay, that's the idea. अगर वो SN1 वाला SN2 वाला याद नहीं आ रहा है, then remember we said that SN2 reactions are favored when कार्बोकेटायन बनने का समय नहीं मिलता है. न्यूक्लियोफाइल अटैक सो क्विकली दैट इट फॉर्म्स द ट्रांजिशन स्टेट एक स्टेप में हो जाता है. न्यूक्लियोफाइल कब जल्दी से अटैक कर पाएगा? जब उस पर कोई बाधा ना आए. नो वन इज एबल टू स्टॉप द न्यूक्लियोफाइल. नाउ व्हाट इज न्यूक्लियोफाइल? न्यूक्लियोफाइल इज अ something with electrons. If I have a H plus over here, which is very small, very charged small species, polar protic solvent, वो आके इस पे चिपक जाएगा, and we don't want that. We want a solvent ताकि reaction हो, but not something that चिपक जाए nucleophiles. We want the nucleophile to be free, right? If nucleophile is free to move around, poof, reaction is good. Yeah, that's why this guy here is the answer. Polar aprotic solvent. Theory revise कर लेना. Anyway, इस वाले का क्या आंसर है? Arrange the compounds in order of reactivity towards SN2 reaction. 1 bromo 3 methyl butane. इसका स्ट्रक्चर बनाना पड़ेगा. आप लोग आंसर बनाने की कोशिश करो. While till that time I'll draw the structure. 1 bromo 1 2 3 methyl butane. Okay, 1 2 3 सब ब्यूटेन है. ब्यूटेन बना लेते हैं. 2 bromo 3 methyl butane. Okay, 2 bromo 2 methyl butane. अच्छा, तो looks like this one is tertiary, this one is secondary, and ये वाला तो primary लग रहा है ना? That's what you've got to identify. मेरे सर के ऊपर आ गया. My bad, my bad, my bad. बिस्वजीत, are you sure? Are you sure? Are you sure? देखो, SN2 में देखो tertiary carbocation is very stable, but carbocation हमको नहीं बनाना है, right? We don't want a carbocation because अगर carbocation बन गया तो that will not be an SN2 reaction. SN2 reaction, no carbocation. So hence the order will be ulta of what Biswajit just said. Yeah, Mohammad Adil and Deepanvita absolutely right. It's this way. Good job. सेम चीज दूसरी तरह से हम लोग पूछ रहे हैं. एक बार ये ट्राई करो. Which is following is the correct order of decreasing SN2 reactivity. Decreasing मतलब कि सबसे ज्यादा रिएक्टिव वाला पहले डालो. सिंपल सा है. सबसे ज्यादा रिएक्टिव कौन सा होगा? It will be the one that's not tertiary. और let's say right most वाला होगा जो tertiary होगा, right? So सबसे right most वाला tertiary इसमें है. This must be the answer. Mark it. Move on. ठीक है? ये वाला इंटरेस्टिंग सवाल है. The major products A and B of the following reactions are what? RX plus KCN and RX plus AgCN. इंटरेस्टिंग क्या है? ये तो डायरेक्ट होगा ना, बन जाएगा साइनाइड. क्या फर्क पड़ता है? RX plus KCN, KCN डाला मतलब कि K plus आयन और CN minus आयन आ गए. अब ये दोनों आयन हो गए तो बन गया RCN, है ना? ये वाला मैं खुद करके बताता हूँ. If you guys have an idea, please give me inputs, but it's okay. I'll solve this one. Right? Look at that, Mayuk. Mayuk enters here with that full music kind of a mode and bam with the answer. Yeah, that's very cool. RNC. RNC. Absolutely right. Why is Mayuk saying RNC, guys? Any idea? I agree with him. Good job. Good answer. देखो, ये जो मैंने बहुत प्यार से बोला कि K plus और Cn minus होता है, this does not happen that easily with AgCN. Now, this is where bonding comes into picture. I've told students a lot कि organic करने से पहले bonding पक्का होना चाहिए. तब लाइफ आसान होगी. सबसे मुश्किल सवाल के लिए. Yeah, electronegativity's idea and all of that. So this is kind of a covalent bond. It doesn't break that easily. Yeah, it has a from Fajan's rule. I'm not going to go into details. So this is nicely bonded. You know, Ag and Cn का bond काफी strong है. Fevicol जैसा जोड़ टूटेगा नहीं and all that. So instead, दूसरी तरफ से नाइट्रोजन यार ambident है. Nitrogen like चलो let me do this. Yeah. So nitrogen bonds with this instead, and what you get is RNC, and then Ag is like यार तुमने अब ले लिया था ना, Ag goes away. Okay, cool. This is very interesting. And something similar happens with if you take AgNO2 as well, right? अगर मैं AgNO2 डालूं, same thing. If I do RX plus AgNO2, what do you think is going to happen now? What's going to get produced over here? Absolutely right, Sahil. Sahil, Deepanvita, Biswajit, absolutely right. Tanu, it's all right, Mayuk, absolutely fine. Good evening, Afreen. How are you doing? ये वाला सवाल देखो. RX plus AgNO2 में क्या होगा? What do you think? Mayuk, are you sure? Are you sure? अब यहाँ पे थोड़ा सा बदल गया चीजें, ठीक है? Ag की बॉन्डिंग, सो दिस बाय थोड़ा नीट में शायद नहीं पूछा जाएगा, इट्स अ लिटिल बिट एक्स्ट्रा. Ag की बॉन्डिंग इज विद द ऑक्सीजन, ओके, इन दिस केस नॉट विद द नाइट्रोजन, एंड बिकॉज ऑफ दैट नाइट्रोजन लाइक यू नो व्हाट, आई एम गोइंग टू बॉन्ड विद दिस R चैप राइट हियर. RX के R के साथ हम बॉन्ड कर लेंगे. सो दिस फॉर्म्स RNO2. थोड़ा ट्विस्टी था यार, सॉरी, माफ करना, ठीक है? गुड इवनिंग मनप्रीत, हाउ यू डूइंग? या RNO2, एब्सोल्युटली एब्सोल्युटली, ठीक है? यू गुड मयूक? Yeah, I know this is a scam question, यार क्या करें, ठीक है? All right. अगला सवाल ये वाला स्ट्रेट फॉरवर्ड है. स्ट्रेट फॉरवर्ड मतलब ठीक है. Now we're back to NEET level. Consider the reaction CH3 CH2 CH2Br plus NaCN gives you this. This reaction will be fastest in. अरे the thing is, मुझे अभी तो आपने एक ही चीज पढ़ी है, मतलब this must be SN2. तो ये because you know this, इसलिए ये वाला थोड़ा आसान है. Otherwise you have to figure out SN2 SN1 होगा क्या होगा, but आपने सिर्फ SN2 ही पढ़ा है, तो must be SN2. Also देखो ये एक प्राइमरी, I mean, this is just a aliphatic chain, right? No branching and all of that. So secondary, tertiary नहीं है. So this is going to go through SN by SN2 itself. And कुछ heat नहीं कर रहे हो, बहुत strong base नहीं है and all of that. So sure, SN2 is the way we're going to be going. Okay. Chandu, what's up? Chandu saying B. Okay. Tanu saying C. Deepanvita saying C. Afreen is also saying C. Manpreet is saying C. Oh, a lot of you saying C. C क्यों बोल रहे हैं आप लोग? मुझे लग रहा है आप लोग C बोल रहे हैं because it's polar aprotic solvent. बहुत प्रैक्टिस कर रहे हैं हम लोग सेम आइडिया को बार बार बताने के लिए, but that's the idea, right? अगर मैंने इथेनॉल या मेथनॉल या पानी डाला तो ऑल ऑफ देम विल सॉल्वेट द न्यूक्लियोफाइल एंड यू डोंट वांट दैट. You don't want that. Okay, good job. C is the answer. Absolutely right, Mohammad Adil. Madhubala, the famous actress, is here. Good job. All right, all right, all right, all right. Okay, next one. Among the following, the strongest nucleophile is which one? ये वाला interesting सवाल है. एम्स का सवाल है. Okay, there are 4 options, and yeah, this is quite interesting actually. NCCH2. अच्छा, तो ये साइनाइड है. CH2 माइनस. ये तो बहुत स्ट्रॉन्ग बेस लग रहा है भाई. बेस तो स्ट्रॉन्ग है, बट okay. Strongest nucleophile है कि नहीं? Let's see. नहीं यार. Okay, I was going to give you the hint. Tanu doesn't want a hint. Tanu wants the answer. Tanu is saying A. Okay. All right. देखो, there is conjugation happening in B and D. ठीक है? This negative charge can move around here. Similarly, negative charge can move around here, which makes the electrons not that freely available. तो इसलिए हम लोग B और D को eliminate कर सकते हैं. And between A and C, electronegativity ज्यादा है. ठीक है? Cool. Okay? All right? Hence, A is the answer. थोड़ा सा मुश्किल सवाल है ये. And this is your theory. I mean, it's a little hard. I'm gonna give that to you. You could eliminate B and D to an extent, but between A and C, you'd be like, अरे यार, क्या करें? Right? So, what is SH? S is below oxygen, right? So, this is just like OH, SH. ठीक है? कुछ नई चीज नहीं है. Hi Vishal, how are you doing? Hey Saloni. Yeah, you guys all right? I know, Mayuk. ये थोड़ा tricky सवाल है. You've gone with a good idea. Yeah. That's a good guesstimate. Yeah, A is the right answer here. चलो, ये बहुत interesting सवाल है. Subjective सवाल. ठीक है. NaOH डाला, DMSO डाला. DMSO डाला मतलब कि again polar, aprotic, solvent, etc. ठीक है. NaOH क्यों डाला? बेस है. ओके, मतलब OH माइनस आयन है इसमें. ठीक है. प्रोडक्ट क्या बनता है इसमें? सोचो, अगर ऐसा बना हुआ है. लेट मी वॉक यू थ्रू दिस क्वेश्चन. व्हाट डज दिस प्रोजेक्शन मीन? इस प्रोजेक्शन का मतलब है कि CH3 और D पीछे की तरफ है और Br और H इज टुवर्ड्स यू. Br इज हियर, H इज हियर. आर यू एबल टू अंडरस्टैंड दिस? समझ में आ रहा है? मतलब ये विजुलाइज कर पा रहे हो? आपकी तरफ है. ये वाला कौन सा? ये Br हो गया, ये वाला हो गया H, है ना? And then behind are CH3 and D. If you want to draw a structure, 3D structure, this is a better way of drawing it, है ना? इस तरीके से देखो कि मैं I'm looking at it from here and towards me I've got Br and H. Are you able to follow? हाँ, dimethyl sulfoxide, Biswajit. It's a polar aprotic solvent. Yeah. दिखेगा. वो last session में दिखाया तो था मैंने. The fancy thing that was there. There was a S and all of that. There was a O. Just check out the last session for details, nucleation and all that. ठीक है? Cool. Are you able to follow this? It's a polar aprotic solvent. That's what you need to know. ठीक है? ये समझ में आ रहा है? What the structure actually means, looks like? Yeah? Are you able to follow this? Once you get this, we will be able to identify how to get to the product. Is this okay? Yes. OH minus will attack, but from behind, right? Because it doesn't give time for this to form a cation. मैं बार बार टाइम बोल रहा हूं. I should not strictly be saying time, right? Everything is right now. हम लोग kinetics की बात sort of thought of कर रहे हैं, नहीं भी कर रहे हैं. Let's just say कि कार्बोकेटायन फॉर्म होने से पहले this attack needs to happen, and that's why this is SN2. Okay, cool. Now when this happens, क्या होगा? Br will nicely go away, OH minus will come, but now see, ऐसा बन जाएगा. Okay, so nothing has changed. Look at this. कुछ बदला नहीं है. मैंने बस इसको इस तरफ से आया तो CH3 इधर था सेम प्लेन में, इधर से बस इस तरफ चला गया, सेम प्लेन, कुछ नहीं हो रहा है. ठीक है. और ये D इधर पीछे था, पीछे ये H आगे था, आगे ही है. बट नाउ इफ यू लुक एट इट फ्रॉम दिस साइड, क्या बन जाएगा तुम्हारा? देखो D और OH तुम्हारे सामने है, राइट? सो जहां पे Br था, अब D आ गया. यू सी दैट? डू यू सी दैट? ये बहुत इंटरेस्टिंग चीज है इसमें. यार जब मैं इस तरफ देख रहा हूं, व्हेन आई लुक एट इट फ्रॉम दिस पॉइंट ऑफ व्यू, जहां D था अब BH आ जाएगा, वो आ जाएगा. सो नाउ इफ आई ड्रॉ द स्ट्रक्चर अगेन, इट विल लुक लाइक दिस. सो इन अ सेंस दिस इज व्हाट इज फॉर्म. ठीक है? कूल. Inversion of configuration, absolutely Walden inversion, बिल्कुल सही बोल रहे हैं आप लोग. But how do you represent it on this structure? Inversion of configuration इसमें कैसे दिखाएंगे? That is what I want to tell you. Very interesting question. But इस configuration में समझना थोड़ा complicated लग रहा है. इस projection में, that's why it changes to this wedge and dash projection. ठीक है? Fisher से wedge and dash में convert किया. Yeah, इससे हम लोग मुश्किल चीज़ नहीं करेंगे. But this is something interesting I thought I'll just share with you. Okay? अगर ये चीज समझ में अभी नहीं आ रही है, Just go back and try and visualize this, looking at it from this point of view. This is the best way to understand it. Okay, कि ये दोनों मतलब जो horizontal है pointing towards you and जो vertical है going away from you. And once this attacks this way, it becomes this. Okay, cool. So ये जो single lines है, these are in the plane of paper itself. जो dash line है वो पीछे है और जो अभी सॉरी जो dash wedge वो पीछे है और यार wedge line आगे है, dash line पीछे. Wedge मतलब कि solid line आगे है और जो dash line पीछे है बस. ठीक है? All right. Mayuk, why did the change take place? Because this was हमने SN2 में किया था ना कि it forms a stable transition state and before the reaction, before the carbocation gets formed, the nucleophile attacks this and there's a bond that's formed like a partial, we did a dot वो याद आ रहा है, right? So neither bond breaks and it's formed like this, and once it breaks it goes out. Just check out last session का हम लोग ने we made a simple sort of animation also to show how this works. Yeah, it's also an NCRT, this transition state. In fact, last session का हमारा जो what do you call it thumbnail था, that itself has this. Yeah, यही transition state. जैसे इस session का thumbnail is transition state of E2, last session का था वो SN2. Okay, is that okay? Yeah, थोड़ा complicated था, I know, but again, very interesting question. Here's another one. This one is more direct. Tertiary alkyl halides are practically inert to substitution by SN2 mechanism because of what? अब ये सोचने वाली बात है, right? मैंने बता तो दिया कि देखो primary is better than secondary is better than tertiary, but why? Why is it? One idea I told you is carbocation form नहीं करने दिया, but क्यों? Carbocation बनने में क्या problem है? सोचो, think about it. Yeah, this also something we've covered in the last class. I know that I do this a lot कि मैं theory पढ़ा लेता हूँ और next session I start completely with questions because I want you to go home and revise. That's the whole point, right? NCRT पढ़ो आओ पढ़ो फिर हम लोग आराम से question solve करेंगे. A. Yes, absolutely right. Steric hindrance. Absolutely right. Absolutely right. Mayuk, ping me on Telegram or something if you still find any issues with this. Steric hindrance. Absolutely right. Madhubala, Afreen Begum, Deepanvita, Shipra. What's up? Tanu, Deepu, Manpreet. Okay, absolutely amazing. ठीक है. All of you are right. Hey, Medico, what's up? Are you doing what do you call it, a dual thing today as well? Hey, absolutely right, Mayuk. Out of the following, best leaving group is what? Now, this is interesting. Yeah, leaving group acha will be a good leaving group, whether it's SN2 or SN1. We'll do SN1 also just right after this. Sahil on Discord? Yeah, sure, dude. On Discord also is fine. Same, I teach Chem. Yeah. Previous question, did not understand? Previous question थोड़ा ज़्यादा था, Biswajit. कौन सा? Steric hindrance वाला? Biswajit, was it the steric hindrance one? Steric hindrance या उससे पहले वाला? इससे पहले वाला, don't worry about it. That was an extra thing that I taught you over and above what I wanted to teach you. Like थोड़ा ज़्यादा, NEET के भी ऊपर, काफी ज़्यादा ऊपर. सब लोग D बोल रहे हैं बहुत. Let me just address this. Yeah. Deepanvita, Vishal, Shipra, Afreen, Madhubala, Sahil, Biswajit, Vishal again, Mayuk, Vishal again, Abhinandan are all saying D. You're doing biology and attending your chemistry. सही है, you're a multitasker, medico. You'll do well in medical school, huh? Medical school में multitasking बहुत करनी पड़ती है. So this is absolutely right. I minus is the right answer. Biswajit, if you're talking about steric hindrance wala, this one is because the whole point is the nucleophile should be able to attack easily, right? If बहुत बड़ा सा group है, it's not physically able to go there and find that site for the reaction to happen. उसी चीज हम लोग steric hindrance बोल रहे हैं बड़े शब्दों में. That's it. If you're talking about the question before this, थोड़ा complicated है. Take some time, rewatch it, or ping me and I'll help you out with that. That was above NEET anyway, so you don't have to worry about it. Okay, all right, cool. Let's move on to the next kind of nucleophilic substitution reaction, yeah, which is SN1 reactions. As you can guess, SN1 is not talking about the number of steps being one. It's talking about the rate of the reaction being dependent on just one species. What is that one species? Rx. It does not depend on the concentration of nucleophile, which is very interesting. But how is it different? अलग क्या है यहाँ पे? देखो, SN1 reaction में it's a two-step reaction. The first step, if you've guessed it already, is the formation. अरे आगे तो जाओ भाई. हाँ, steric hindrance नहीं सर, इसका previous question. Steric से पिछला वाला उसको छोड़ दो. Don't worry about it. Where I said DMS on all the right, it's okay if वो नहीं समझ में आया. That's above, way above NEET. Ping me separately on Telegram. I'll help you with that. Yeah, it's a two-step process. Unimolecular two-step. Absolutely. First step is the formation of carbocation, and this is the slow step or the rate determining step. What is the RDS? I'll talk about that quickly. The next step is the attack of the nucleophile. So now it's like nucleophile chill कर रहा है भाई, ठीक है हम आएंगे. I will come. First you form your carbocation. What's the hurry? That's what's happening over here. And because of this, something interesting happens. A carbocation is a planar species. Okay. because of which you get a racemic mixture at the end of the whole thing. And also, because of this formation of carbocation, it does some really funky things. बहुत अजीब-गरीब चीजें करता है. Carbocation के लिए कुछ बनने के लिए कुछ भी कर जाएगा, right? What is stable? A tertiary carbocation is more stable than secondary, more than primary, right? You know this already. And this step, formation of this carbocation, that's the slowest step. Okay? Cool. After that, ठीक है भाई, nucleophile आएंगे आराम से, and whatever it is, will attack to this. This is fast and बन जाता है. ठीक है तुम्हारा product. And then पानी निकल जाता है. That's the last step. That third step, deprotonation goes away. Water H3O plus goes away, and you have this. I said pani, I meant H3O plus. My bad. And this is what you get in the end. Okay, so here's the whole deal, right? Now you may be asking, अरे ये तो बहुत बड़ा group है, क्यों टूट जाता है? Because it doesn't matter that the group is big. In fact, it's a good thing if it's a branched group like this. Wait, इस तरफ. Yeah, look at that. This is a very, very stable carbocation. Okay. Now when I said planar, I meant that the whole species. This may not look very planar. The carbon atoms are in the same plane is what I mean to say. Okay. You're like, what do you mean by planar, right? The carbon atoms, this guy and what's connected to the rest of them are in the same plane. So now water can come from this side or from the other side. Is that going to show up? Hold on, let me see. दूसरी तरफ आ रहा है? Nah. This is just showing the three steps. First step slow, second step fast, third step also fast, which is taking away of protonation. Deprotonation. Taking away protonation? That's funny. Okay, yeah. And third 3 electron donor. Okay, Sahil, what's up? Great, cool. So unimolecular two-step process. Unimolecular matlab it only depends on the concentration of Rx. Every time I write this, I mean concentration. All right, okay. Where in the rate expression, rate is proportional to this. Okay, cool. This is an intermediate form, which is carbocation. That was very cool. Do you have a phone? Where did that noise come from? Because my phone is silent. That's funny. I heard a very, very muffled sound. What? My mind's playing tricks on me. Anyway. So anyway, remember मैंने बोला था कि बहुत अजीब चीजें होती हैं because carbocation form होता है. This is what I mean. Okay, a rearrangement is possible inside the molecule itself because it will do anything to get to a more stable carbocation because that is the rate determining step. तो सबसे slow, सबसे आराम वाला step वही है. What does this rearrangement mean? I'll talk about it in just a minute. Okay, first let's talk about something a little even more interesting. It doesn't care about the concentration of nucleophile. You know how big a deal that is. पहले हम लोग SN2 में we were talking about nucleophile being the king, like all hail nucleophile. Here, like yeah, whatever, any nucleophile, you know, will do. But here is the interesting thing. ठीक है? अगर तुम्हारा rate only depends on this, so if you have one type of nucleophile, this sort of reaction happen. If you had another type of nucleophile, the other reaction happen. Right? That's how you decide SN2 और SN1 के बीच में क्या होगा. If that's something you want to do. Okay? खैर. What is rate determining step? अगर ये चीज आप पहली बार लाइफ में सुन रहे हैं तो in a multi-step reaction, it's one step that's a lot slower. In kinetics, we have done this in detail. I have a kinetic session coming up with you tomorrow, right? This is going to come up कल भी. कल शाम को 8:30 बजे we'll meet and we'll do questions on this. Very interesting question. ठीक है. सबसे slowest step को बोलते हैं. तो look at it this way. Yeah. If you've got a narrow opening over here, तो उसकी बाद वाली opening अगर ज़्यादा बड़ी हो भी, it doesn't matter because this opening is narrow. And this determines the rate of the reaction. And this your narrow वाली opening could be here or here or here, could be anywhere. वो तो बस आपको दिखाने के लिए यहाँ पे पहली बार डाला है because in this case carbocation is the first step, right? So it's similar to that. So it doesn't matter अगर बाद वाली openings बड़ी हैं because that is the rate determining step. It's as simple as that. ठीक है? Small illustration. Pretty sure you didn't need this, but here you go. Okay, if you did not know what the rate determining step is. ये कितनी बार चलेगा भाई? रुको, लग रहा है भाई साहब अटक गए. अगले वाले पे जाते हैं. All right. ठीक है. What are the factors that affect SN1 reaction? The first one is the nature of your alkyl halide. You know this one, right? Tertiary greater than secondary greater than primary. So this I've already told you, right? But why? Because 11th grade. Okay. If you're going to ask me why is tertiary more stable, a little difficult for me to get into right now. Hold on, just one sec. कहाँ पढ़ा था आपने? GOC में? General Organic Chemistry or was hydrocarbons? I think it was hydrocarbons. I don't remember. But 11th grade, basically. But look at the rates, okay? If you want to see real life stuff, the relative rate is this. You remember, SN2 में भी हमने ऐसी exercise की थी and rate was something like this, right? ऐसा कुछ था in this order, right? Primary, secondary. Look at this. Look at SN1, SN2. This was in SN2. If you don't remember this, last वाला SN देख लेना. SN1 का rate देखो. 12 लाख गुना as compared to मतलब प्राइमरी होता ही नहीं है SN1 में. Okay. Good evening, Sandeep. How are you doing? खैर, okay, quick question. Which of the following gives the fastest SN1 reaction? सबसे तेज SN1 रिएक्शन कौन सा देगा? जस्ट चेकिंग अगर आप लोग सो रहे हैं या फिर उठे हुए हैं. ऑल राइट संदीप, वीडियो की यही तो खूबियत है, कभी भी देख सकते हो. या यू कैन रिवाइंड इट एंड सी इट लेटर. एग्जैक्टली मयूक. What do you think? What's the answer to this one? Which of the following gives the fastest SN1 reaction? SN1, okay, not SN2. SN1 यानी कि tertiary greater than secondary greater than primary. क्यों? क्योंकि हम लोग कार्बोकेटायन बना रहे हैं. यहाँ सिंपल वन. दीपान्विता is saying D. Absolutely right. बहुत सिंपल सा सवाल है. एक और देखते हैं. मयूक, yes, absolutely right. Which of the following gives the fastest SN1 reaction? Madhu, absolutely right. How about this one? इसमें क्या होता है? What about this one? Yeah, Manpreet, absolutely right. Sandeep. I'm going quickly over this because यार ये सब बहुत basic चीजें हैं. And if you want me to slow down, repeat anything, let me know. Tanu and Afreen, absolutely right. D is the right answer. इस वाले का क्या होगा? इसमें सबसे फास्ट है. यहाँ पे साइक्लिक कंपाउंड है तो कुछ फर्क पड़ने वाला है? नहीं, not really. This is primary. This is secondary. This is also primary. मतलब आंसर होगा आपका ये. This is tertiary, है ना? B must be the answer. Mayuk, yes. D was the last one. Deepanvita, absolutely right. This is the right answer for this question. Tanu, yes. Two simple questions. Madhubala, absolutely right. Good job. Next one. What is the nature of the nucleophile? अब मैंने बोला था कि rate does not depend on the concentration of nucleophile. It does not depend on concentration. But the type of nucleophile decides कि SN2 reaction होगा या SN1 reaction होगा. Yeah, that's important. Absolutely right. Mayuk, Afreen and Madhubala. The last answer was option B. The rate is not affected by the concentration, but only weak and neutral nucleophile favor SN1 reactions. Okay, this is important. If you have a strong base, something else could happen entirely. Actually, I was going to say maybe SN2 happens, but it's also possible elimination could happen. But if you have, say, a polar protic solvent, in this case, मैंने आपको आगे का part बता दिया, a polar protic solvent and this guy here, then you have an SN1 reaction. I'm giving you things for the next session, right? You're gonna, the main thing after you study all this, like point क्या है, for you to be able to figure out कि अच्छा ये reaction हो रहा है तो what's going to happen? Is it going to be SN1, SN2, E1 या E2? ये E क्या है? Elimination. मैंने स्टार्टिंग में बताया था कि हो सकता है कि भाई डबल बॉन्ड बन जाए instead of all of this, right? So that's the point of studying all of these things in detail. Okay, cool. खैर, so अगर हम लोग सॉल्वेंट डालें तो पानी होगा तो उसको हाइड्रोलिसिस बोलते हैं, एथेनॉल होगा तो एथेनॉलिसिस बोलते हैं. कूल. And it's also called a solvolysis reaction. The reason I'm giving you this terminology is because NEET has at times said कि solvolysis से क्या होता है? जैसे ही शब्द solvolysis दिखा, मतलब हो गया SN1 reaction. Okay, cool. Nature of solvent, I've already given you a hint. It is a polar protic solvent that favors SN1 reactions. Now, why would that be? Remember, न्यूक्लियोफाइल में क्या प्रॉब्लम थी पोलर प्रोटिक सॉल्वेंट डालने में इन SN2? वही यहाँ पे हमारा सोल्यूशन है. लिटरली, नो पन इंटेंडेड. वेल, पन इंटेंडेड. अगर तुम पानी डालो या कोई भी पोलर प्रोटिक सॉल्वेंट, पोलर प्रोटिक समझ रहे हो ना? पोलर प्रोटिक का मतलब क्या है? या नो डाउट है, राइट? कुछ डाउट है तो पूछ लो. पोलर प्रोटिक सॉल्वेंट यानी कि व्हाट इट डज इज दैट इट प्रोटेक्ट्स द न्यूक्लियोफाइल. But that's not a good thing, right? It is. It protects the nucleophile and it protects the X minus, the leaving group, and it protects the carbocation. It solvates all of them. And that's beautiful because the rate determining step is the formation of carbocation. So anything that is, good for the formation of carbocation is good for SN1 reactions. इसीलिए हम लोग यहाँ पे polar protic solvents यूज करते हैं. वही चीज अंग्रेजी में यहाँ पे लिखी हुई है. Using a polar protic solvent will greatly increase the rate of carbocation formation of an alkyl halide in any SN1 reaction because of its ability to solvate cations and anions effectively. कौन से cations, कौन से anions? ये हमारा हो गया leaving group Lg, right? और ये हो गया हमारा cation and nucleophile भी भाई हो जाता है solvent. Okay? Patil, Preeti Patil saying B for the last one. Okay, cool, great. वही था. The last one, leaving group ability मैंने बताया था same होगा. It's simple है ना? बड़ा leaving group goes away happily. It's good. Okay? Cool. इसमें nothing has changed, so I'm not going to spend too much time on it. Iodine is, goes away much easily than bromine, then fluorine. I should technically be saying iodide, bromide, chloride, and fluoride, but you get भावना लोग समझ गए. नाउ स्टीरियोकेमिस्ट्री का मैंने आपको आइडिया दे दिया था, बट लेट्स मेक इट फॉर्मल, राइट? व्हाट्स द स्टीरियोकेमिस्ट्री ऑफ द SN1 reaction? In SN2 reaction, Walden inversion happens, okay, because backside attack, etc., etc. Here, when a carbocation is formed, that's a planar compound, okay? Look at this. Planar matlab the carbon, the central carbon. I'm talking about the one that develops the positive charge, okay? So the nucleophile can attack the carbocation from two different sides. Two different sides. sp2 है मतलब कि एक p ऑर्बिटल तुम्हारा खाली बैठा है. One p orbital is chilling, okay, and that is where the electrons come, okay. So you can say कि सामने या पीछे दोनों से भी आ सकता है, but technically ऊपर या नीचे, but it's okay. सामने पीछे ऊपर नीचे, it's alright. It's the same. It's okay. Don't worry about the. It's the same thing. Now you want to see this happen? This is what happens, and hence what you get is a racemic mixture. Racemic mixture मतलब कि you get almost equal quantities of this, but hold on. इस स्लाइड पे बात करें, I'll tell you there's a disclaimer. The disclaimer. Almost equal, I said, right? Disclaimer. खैर, ये पहले चला गया. This is your RDS, right? And then उसके बाद होता है next step. This is the fast step when nucleophile attacks. Now you see, p orbital में या तो ऊपर आ सकता है या तो नीचे से आ सकता है. In this case, retention of configuration होता है. नीचे से आया तो inversion of configuration हो गया, right? So theoretically, it should give you a racemic mixture, but it gives you the inverted product थोड़ा सा ज़्यादा. That's why I said disclaimer. This is the disclaimer. Okay? All right? Any doubts here? Yeah? Practically, you get a slightly higher proportion of the inverted product in SN1 reaction. बहुत अच्छा कहानी वाला सेशन हो गया, है ना? खैर, this is what it actually looks like, right? Here is your ion pair, and then you've got this planar compound here, nucleophiles attacking. Attack karo bhai. Where are you? Oh, there you go. Nucleophiles attacking. Can attack from both sides. Good evening, Poonam. How are you doing? And you can get two different things, which are racemic mixture, but slightly greater than 50 is what is formed. Okay, a question. In SN1 reaction on a chiral center, there is a CH3O minus as a solvent, I suppose. What is this? NEET 2015 का सवाल है. Okay. Well, since NEET का है तो मैंने डाल दिया है. थोड़ा सा weird question, but anyway, let it in because it was a NEET का question. Inversion more than retention leading to partial racemization. 100% inversion, 100% retention. Probably not C and D, right? Because C is for SN2, right? But 100% नहीं होता है. Major product होता है. 100% life में कुछ नहीं होता है. खैर, answer must be B. I said it's weird because you can kind of तुक्का मार के तुम B मार्क ही कर सकते हो, right? मयूख, दीपान्विता, पूनम, शालन. Oh, Shalan Shandu, what's up? Viswajit, good evening. Answer is B, absolutely right. I said थोड़ा अजीब था क्योंकि तुक्का मार सकते हो. Guess this answer and you'll do a good job of it. Now, I'm going back and saying बार-बार life में guess नहीं करना चाहिए, right? But this is not a guess. I have eliminated two options and option A seems like junk, right? So I'm marking B. This is not a guess. Yeah, all right, cool. Here's an example of an SN1 reaction. This is what happens. Now, if you're going to ask me, मैं Ag plus उसमें क्यों डाल रहा हूँ? You'll see sometimes Ag plus होता है. क्यों? क्योंकि AgBr is a precipitate. Okay? That is why sometimes you will see Ag plus or salts of Ag being put into solution. या फिर AgNO3 भी डाल सकते हो. Ag plus कहाँ से आता है? AgNO3 कहीं से भी आ सकता है. ठीक है? Good night, Shalan. Good evening and good night. Logical guess. Absolutely right. Absolutely right, Sahil. Absolutely right. So this is what happens here, and CH3OH से H निकल जाता है और CH3O ऐड हो जाता है. ठीक है? Cool? We good? Question clear दिखाई नहीं दे रहा है अफरीन. अरे maybe you need to go in your mobile settings. वो top right पे होगा शायद. कहाँ पे? हाँ, right पे जाके advanced में जाके change the setting to 1080p. कभी-कभी अपने आप 360 या 480p पे हो जाता है, right? Just change that. Okay. Yeah, exactly, to get out BR. Here's another one, right? मैंने सिर्फ पानी और AgNO3 डाला. अगर मैं सिर्फ पानी डालूं तब भी OH बन जाता है. ठीक है? That's the amazing thing about SN1 reaction. Cool? And जैसे मैं बोला था, AgNO3 goes in there. And you get both of these. More of which one? कौन सा वाला था? Inversion वाला? ये. More of this. More of this. Okay. So to recap SN1 reactions, partial racemization, unimolecular, proportional to Rx. The rate is proportional to Rx. Alkyl halide reactivity is this. Weak nucleophiles are good. Two-step reaction and polar protic solvents are good. Any doubts so far? Any doubts? नहीं नहीं नहीं. एग्जाम में कभी तुक्का नहीं मारना चाहिए दोस्त. एग्जाम में कभी तुक्का नहीं मारना चाहिए. अच्छा हाँ, माफ करना साहिल. या you're right. 720p डाल लो. 1080p अगर भारी हो 720p डालो, 720p से कम करोगे तो शायद ब्लरी दिखेगा, बट एक्चुअली चल जाएगा। मेरा चेहरा ब्लरी है, क्या फर्क पड़ता है? 480p ऑल्सो वर्क्स, टेक्स्ट तो साफ दिखेगा। I have made this. I know that a lot of you view this on the mobile. Okay, we do a lot of analysis on the back end. Thanks for bringing it up. We know that around 80% of you are on cell phones. Okay, so we've made the session so that इतना बड़ा text हो ना, इतना बड़ा bold text हो कि 480p पे भी तुमको आसानी चल जाएगा। 720p is ideal, 1080p तो best है। ठीक है, तो I'm streaming in 1080p, but you can watch 720p or even at 480p अगर नेट का इशू है तो। But interesting, thanks for bringing that up about internet. Yeah, I know it's a real thing. विश्वजीत, guess नहीं करना चाहिए लाइफ में, कभी नहीं, कभी भी नहीं। ठीक है, एजुकेटेड गेस इज नॉट अ गेस, इट्स एजुकेटेड, राइट? खैर, इस प्रोडक्ट का क्या रिएक्शन बनेगा? नाउ आई एम गोना वॉक यू थ्रू दिस वन. If you have answers, please give them in the chat, but I'm going to teach you this one. What's the major product of this reaction? मैंने सिर्फ पानी डाला, कुछ किया ही नहीं। पानी डाला तो क्या होगा? ठीक है, पानी डालने से भी रिएक्शन हो जाता है। क्यों? क्योंकि I is a very good leaving group. I minus आसानी से निकल जाएगा। ठीक है, अगर मेरे पास Br होता है, कुछ और होता है, तो maybe I'll have to put AgNO3 in the solution also to do it. But because this works. So I get a carbocation for sure. ठीक है, but the reactant, the product that I get finally is this. For tab 360 enough, okay Mayu, good to know, good to know. अच्छा, I haven't tried on a tab. मोबाइल यार प्रॉब्लम है कि रेजोल्यूशन बहुत हाई होता है मोबाइल पे, तो इसलिए 360 थोड़ा ब्लरी लगता है। अगर हाँ टैब पे मे बी ऑन द आईपैड और इवन ऑन द सैमसंग टैबलेट्स, आई थिंक लेनोवो आल्सो मेक्स गुड टैबलेट्स, उसमें भी चल जाएगा, राइट? सो लुक एट दिस रिएक्शन, लुक एट दिस, आई हैव मेड समथिंग वेरी फंकी हियर। ये बहुत अजीब चीज मैंने बता दी है। दिस इज अ कार्बोकैटायन वाला स्टेप, दिस इज ओके, बट यहां से मैंने व्हाई ऑन अर्थ डिड आई डू दिस? इट लुक्स लाइक ये वाला मिथाइल, लाइक it did some gymnastics and went over here, and that's exactly what happened. This is called a methyl shift. क्यों? Remember, मैंने बोला था कि SN1 reactions में कार्बोकेटायन बनना is the most important thing, और अगर कार्बोकेटायन बनने में थोड़ा सा मिथाइल या हाइड्राइड या कुछ शिफ्ट हो जाए तो चलता है। ठीक है, and that's the most interesting thing. Rearrangement possible है in SN1 reactions. Most likely नीट में ये नहीं पूछा जाएगा, hopefully, but अगर पूछा जाए तो be prepared. Okay, what you get is this. So the OH will still come on this, इसी पे आएगा, but इस पे you see that a tertiary carbocation is possible because अगर मैं इसको alpha position बोलूं तो बीटा पोजिशन पे, मतलब नेक्स्ट पोजिशन पे हाइड्रोजन नहीं है, इसमें CH3 है, हाइड्रोजन मूव करने से फर्क नहीं पड़ता है, बट अगर हाइड्रोजन मूव भी करने के चांसेस हैं। ठीक है, दिस केस यू गॉट अ मिथाइल ग्रुप, मूव्स, makes it a tertiary carbocation, and this gets formed. Is this okay, guys? Yeah, a little bit of theory to show to you कि कैसे methyl shift होता है in SN1 reactions. Rearrangement is possible inside the compound itself. Okay? Hey, good evening, Suru. Yeah? Okay, cool. Is this okay? Is this okay? This is an SN1 reaction. Okay? Polar protic solvent. Pani is a polar protic solvent. Which of the following is least reactive in a nucleophilic substitution reaction? Nucleophilic substitution, इसमें तो generally लिखा है nucleophilic substitution. It doesn't say SN1 या SN2. Just says nucleophilic substitution. मतलब यहाँ पे थोड़ा दिमाग लाना पड़ेगा. Okay? All right. Good that you guys follow. What do you do with this one? इस सवाल को कैसे टैकल किया जाए? So okay, I think this one is good for SN1. Okay. And this one is good for SN2, है ना? तो ये दोनों आंसर नहीं होंगे। अब बिटवीन B एंड D क्या हो सकता है? ये है तुम्हारा अलाइल कार्बन, यानी कि sp3, तो ये फिर भी चल सकता है, मतलब दिस कुड स्टिल डू, बट दिस गाय, ये तो भाई नहीं। व्हाट इज रॉन्ग विथ यू? इसमें डबल, नॉट विथ यू गाइस, मैं अपने, लाइक आई एम टॉकिंग टू माई सेल्फ, लाइक फॉर राइट, यू आर ग्रेट स्टूडेंट्स, यू कांट एवर थिंक, आई कांट एवर थिंक कि भाई ये हो सकता है। तो इसमें अगर if there is a positive charge on this, that would be like all hell breaking loose. So that's not going to happen. Hence this is your answer. Very interesting question. अगर ये विनाइल अलाइल वाली चीज याद नहीं आ रही है, मैंने स्टीरियो केमिस्ट्री में डिटेल में किया था ये, विनाइल ग्रुप, अलाइल ग्रुप, स्टेबिलिटी एटसेट्रा एटसेट्रा। दीपान्विता, which one? हाइड्राइड शिफ्ट कहां पे इस सवाल में? I'm trying to understand here. इस सवाल में कहां पे हाइड्राइड शिफ्ट हो रहा है? Or you're talking about the last question? Hold on. In the last question, why not hydride shift? What does the hydride shift accomplish? Deepanvita, yeah. If it gets you a better, more stable carbocation, then good. But if it doesn't, it's not useful, right? That's why I said that there's a methyl shift happening over here. Or maybe I didn't follow your question. Hydride shift कहाँ पे आप बोल रही थी? And also there is no hydrogen here. There is no hydrogen, right? Hydrogen move भी हो जाएगा, so it will just form a regular this thing, right? So it's not going to help in this case. Okay, cool. If you have a specific reaction where you feel that a hydride shift may happen, send it to me and I'll check it out on Telegram or Discord. I teach Chem, I'll check it out. But usually, I mean, at NEET, I don't think they're going to test that, but sure, I'm here to help anyway. Yeah, bhejega. All right. Which of the following, this is on Discord and on Telegram, which of the following can undergo reaction by SN1 mechanism? SN1 की हम लोग बात कर रहे हैं. 4 options है, benzyl, allyl, tertiary butyl और all of these. हाँ, all of these. जब भी all of these देखते हैं ना हम लोग, यार थोड़ा डाउट हो जाता है. या तो हमेशा all of these होता है, all of these होता है, या फिर कभी भी नहीं होता है. It's like such a 50-50. For people who guess, it's their worst nightmare. Right? ले मार्क करे ना करे, मार्क करे ना करे. हम लोग गेस नहीं करेंगे, हम लोग यही कर देखते हैं. इसमें तो होगा. Allyl है sp3, right? So to this you have an X. Benzyl है this, right? Now SN1 reaction मतलब कार्बोकेटायन फॉर्मेशन. Oh, benzyl, अरे ये तो फिनाइल हो गया. Sorry. My bad. This is benzyl chloride, right? Quickest will be C. I agree. Quickest will be C. But ये सब भी रेजोनेंस स्टेबलाइज्ड हैं. रिमेंबर पिछले सवाल में मैंने बोला था कि देखो एलाइल भी हो सकता है. ये sp3 है तो the reaction can happen. The reaction can happen in this as well. Right? So कैन वाला हम लोग क्वेश्चन पूछ रहे हैं. कैन इट हैपन और कैन इट नॉट हैपन. मैंने पिछले वाले में बताया कि यस एलाइल हो सकता है, sp3 है और ये नेगेटिव चार्ज पॉजिटिव चार्ज होगा, इट कैन गेट स्टेबलाइज्ड. दैट्स ग्रेट, दैट्स गुड. सो एलाइल होगा, बेंजाइल भी होगा, टर्शियरी ब्यूटाइल क्लोराइड होगा ही, हेंस डी. I do not follow what that word means, Mr. Manan Vyas, Dr. Manan Vyas. Yeah. C, quickest is C. I agree. I agree. Quickest is C. But हम लोग पूछ रहे हैं कि is it possible or not? इसीलिए it's all of these. Okay? Yes, Mayuk. Good job. Absolutely. Right? So we have established that A होगा for sure, C भी होगा, और here is the fun thing to do now. अगर A और C होगा and you're confident, then mark D and move on, right? Because एक ही आंसर सही हो सकता है इसमें, right? And it's a neat में. So if you're confident that both this and this are correct, then mark D. And allyl तो होता है, that if you don't remember, that's okay. But yeah, read that up if you're not sure about that. ठीक है, एक और सवाल. For the following solvolysis reaction, solvolysis मतलब SN1. Give the major products. Major product. AgNO3 डाला, aqueous AgNO3. Just saying कि पानी and AgNO3. ये भी सिंपल है, कुछ नहीं होगा, आयोडाइड निकल जाएगा और आपका बनेगा ये आयन. That's it, cation बनेगा. This is what gets formed. Cool. Is that all right? Yeah. Let's move on to elimination reactions. Yeah. Quick. Question last वाला था. Elimination reactions में एक बहुत फंकी चीज होती है. मैं अगर सेम चीज में थोड़ी सी कंडीशंस ज्यादा भारी कर दूं, देन डबल बॉन्ड बन जाता है. कंडीशंस भारी करना मतलब इफ आई जस्ट हीट, पानी में डाला है ना हीट, देन इंस्टेड ऑफ एन अल्कोहल फॉर्मिंग, डबल बॉन्ड बन जाएगा. मतलब सब चले जाएंगे. अरे भाई, वी डोंट वांट दिस. X will go away, H will go away, डबल बॉन्ड बन गया. Similarly, instead of a weak base, if you use a strong base, then I'm like, भाई, yes, we'll form double bond. We don't want to do this whole substitution business. So let's look at the option where you have what is the elimination reaction. पहले हम लोग डिस्कस कर रहे थे. I know I've done it in stereochemistry, but फिर से एक बार बता देता हूँ. If I'm able to remove this compound, I've got W and X say substituted. Usually in most of our discussions, W is going to be H. If you're able to remove this, and you'll see that I've written this in a very funny way. मैंने W ऊपर लिखा है, X नीचे रखा है, and this has a reason. I was thinking regioselective, एंड बोलना था रीजन और बन गया दोनों का रेजोनेंस हाइब्रिड ऑफ रीजन. एनीवे, this is a regioselective reaction, which means that this will happen only if these positions are anti to each other in carbon. Anti मतलब opposite sides. Again, I have done this in stereochemistry. I have given you an idea कि ये होता है और मैंने एक्चुअली मैकेनिज्म भी बता दिया था. ब्रोमोनियम आयरन बनता है एटसेट्रा, वो सब बोला था. ब्रोमिनियम आयरन बनता है. आई डिड ड्रॉन द रिएक्शन मैकेनिज्म एज वेल. भाई वी वोंट गो टू दैट मच डिटेल राइट नाउ, बट मेन आइडिया ये है कि एलिमिनेशन में दो एटम निकल जाते हैं और एक पाई बॉन्ड बन जाता है. दिस इज योर गुड ओल्ड पाई बॉन्ड. ओके, कूल. एंड दिस आल्सो नोन एज 1-2 एलिमिनेशन. 1-2. ओके, 1 मतलब कि X over here, or beta elimination because alpha is the carbon that has your functional group, which is X in this case. Functional group matlab the halide itself. Okay, we good? But its inverse form is more produced. Mayuk, sorry, I did not. Option A is most resistant, right? Mayuk, I didn't understand किस चीज की आप बात कर रहे थे. We have skipped something. Let me know, yeah. So here the hydrogen attached to the beta carbon, that's the one that goes away, and the halogen attached to this guy is called the primary thing. Now, if you're going to ask me, hey, wait a minute, what if there are 2 beta hydrogens? Yes, yes, don't worry, हम लोग करेंगे. अगर एक से ज्यादा हम लोग करेंगे. पहले understand this. This is what was the thumbnail. But इसमें कुछ और था. There was some B and some bonds and some X and something else over here. वो क्या था? There are two types of elimination reactions. Just like SN2 and SN1, they are E2 and E1, and they're very similar. And they compete with each other. तो अगर SN2 हो सकता है तो E2 भी हो सकता है. अगर SN1 हो सकता है तो E1 हो सकता है. In the next session, we'll see कि which, what are the reasons, what are the मतलब किस condition में होता है. I've given you hints already, right? If you increase the temperature or if you increase the concentration of the base or you make it a very strong base, then one thing, usually elimination takes priority. But it's okay. We'll do that in detail next session. Okay. What is E2 elimination? Yeah. 2 groups get away simultaneously. And again, 2 is referring to the rate. Bimolecular elimination. So rate is going to depend on what? Rx. And in this case, nucleophile? Yeah, sure. But let's just call it a base for now. Okay? Okay? I'll tell you why I'm saying base. I'll tell you why I'm saying base. Okay? Not saying nucleophile anymore. Because it's not substitution. Substitution was nucleophilic substitution. हम लोग elimination की बात कर रहे हैं. Okay? Dehydrohalogenation is also something that it's called. You remove hydrogen and halogen right next to the hydrogen. Okay? Halogen and hydrogen are right next to each other on 2 carbons right next to each other. Okay? This is the overall reaction. Just garam karo, kuch nahi karna hai, and you get this. Okay? What do? You use hot alcoholic solution of KOH or TTO and ETOH. Why? What does this do? Hot alcoholic solution of KOH. Alcoholic solution of KOH basically forms yahi to banata hai. That's what it does. Yeah, KOH will give you OH minus ions, right? Yeah. And what else you have? You have ET, OH, and so ETO combines with K. So yahi cheez banta hai. Cool. Any questions over here as to how this is the same thing? आप लोग बहुत जगह देखेंगे alcoholic KOH and heat. This triangle just means heat. Or you will see this sort of a thing. They both mean the same thing. So in this case, I use this as a reagent or NaNH2. I think शुरुआत में किसी ने NaNH2 बोला था. The chat is awfully quiet. Every time I do something that is a little bit theory based, it tends to happen. So I'm just checking it. सब लोग ठीक है? All good? Yeah. सब समझ में आ रहा है? We're okay? Yeah. We'll go through the mechanism of the E2 reaction. Maybe that will wake you up. Here's the base abstracting the proton over here. Iske, if this is to go away, the electrons over here go here, form this pi bond, and at the same time, ye electrons yahan nikal jate hain, and what you have is this X over here. This was the thumbnail. There is a slight delta minus charge over here, slight delta minus charge over here, and yeah, this is the mechanism. Is this okay? Wait, just gonna check. सब ठीक तो है? वीडियो चल तो रहा है भाई? कोई कुछ बोल ही नहीं रहा है? We good? Okay, yeah, I heard myself. So good. We are good. Okay, sweet. So if I take this to be the base, what's the overall thing? What's the overall reaction? अगर ये थोड़ा funky लगा. Here's the base. Okay, it's attacking Rx, which is your halide. Base has a negative charge. This negative charge comes to the hydrogen, takes it away. And where does the base come from? I have NaOH O whatever, etc., 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 right? Remember ETO minus slash ETOH. This is what this whole thing is, okay? Uska counter ion is this guy right here. And then when I attach it this way, what I have is my eliminated product. Okay, cool. All right. So single step biomolecular reaction, second order reaction, RX, and दूसरी चीज क्या थी? Base, not nucleophile, base. Okay, cool. Rearrangement is not possible. We'll talk about it in E1 because there's no carbocation forming. कुछ नहीं हो रहा है, right? The orientation of the proton and the leaving group should be anti. I have given you hints on this point number 5. Yeah. We won't go into too much detail, but this has to do with the formation of an ion. If you want to go through the detail, again, stereo wala session dekh lena. I have explained this in a little bit. This is not going to be tested in NEET, but this is something for you to know. Okay? Beta hydrogen eliminated by the base, so it's called beta elimination. That's it, as simple as that. Okay. Now, अगर एक से ज्यादा बीटा पोजीशन है, बीटा हाइड्रोजन अगर एक से ज्यादा है, तो कौन सा हाइड्रोजन निकलेगा? This is figured out by this amazing scientist called Z-Sef. If you're wondering why I'm saying Z-Sef and what is this weird thing here, he's a Russian guy, but he published, most of his papers were published in Germany, and in German, this is very interesting. S is pronounced as Z, and Z is pronounced as S. Actually, this is pronounced as TS. Z is pronounced as S, and S is pronounced as Z. Okay, so his name is Z-Sef. Okay, but everybody writes Z-Sef because that's how he wrote his name in German publications. Khair. Anyway, little bit of interesting information there. This guy, he did something phenomenal. He said कि देखो, अगर एक से ज़्यादा हाइड्रोजन है, अगर एक से ज़्यादा बीटा हाइड्रोजन है, this is 1, this is 2, then what gets formed is a product that is more substituted. That's all he said. That's all he said, right? So this is Z-Sef, oops, or we can also call this Z-Sef product, SEV. That's how he pronounces it. Khair, V is pronounced as F. This is the Z-Sef product, and this is a Hoffman product. Again, not in your syllabus, but just a little bit extra information. Okay? Cool. Which is formed when? It depends on which substrate, मतलब जो आपका जो हाइड्रोजन है, वो एंटी पोजिशन पे है कि नहीं. ठीक है? अब from this you can't really tell कि एंटी पोजिशन है कि नहीं है. And you don't need to. It's okay. मैंने जो sin और एंटी वाली चीज आपको बताई is above need. I'm just giving you information so that you don't feel कि भाई randomly bunk कर रहे हो. Okay. More substituted is Z-Sef. This is what is usually formed. In exceptional cases, Hoffman is formed when there is selectivity involved. Okay. Cool. All right. Awesome. So characteristics की क्या है? Reactivity again towards E2. Your good friends iodine, as usual, is very, very reactive. Tertiary is greater than secondary, is greater than primary. Why is this? Because देखो, ये जो, now this is where things get interesting, right? In SN2, we said primary greater than secondary, greater than tertiary, right? Why? Because वहां पे हम लोग चाहते थे कि nucleophile attack करे. इधर we have a partial bond being formed in the transition state. अगर ये partial bond बन रहा है, in that case the carbocation, well, not really is formed, but tertiary carbon is a lot more stable. Okay? Hey, Medico. What this person is like a genius right here, right? Doing integrals, doing biology, and then chemistry. That's great. That's awesome. That's awesome. We're integrating all disciplines together, huh? You're gonna make a great doctor, Medico. Khair, what are the factors that affect rate of E2 reaction? ये थोड़ा muggy लगा, I know, the last bit, rate of E2 reaction, because usually SN2 is first primary, secondary, tertiary, और इसका बिल्कुल opposite है. This is not in a syllabus. I'm not going to go into too much detail, but the one line that's in NCERT is कि because a transition state is formed in that has partial character, partial double bond character, तो इसीलिए हम लोग जो है tertiary को prefer करते हैं because that would get formed from the carbocation itself. Okay, cool. What are the factors that affect rate of E2 reaction? Alkyl halides, बता था आपको, tertiary better than secondary, better than primary, right? This is done. Nature of the base. Now this is interesting. When you have a strong base, okay, concentration may not matter. Oh wait, concentration matters. Concentration matters. My bad. High concentration and strong base. Both of these things are good, okay, for E2 reaction. Similar to SN2, but in this case, in SN2, you would have, well, it's okay. The base, you don't heat it. No heat, okay? That's important. If you don't see heat symbol, it's probably SN2. It could also be still be E2, but yeah. Nature of solvent, same as SN2, okay? Here you go. Oh, hold on. nature of solvent is this guy right here, right? It depends on what your reagent is. So agar if I want EtO minus to react, then I put it in EtOH because it solvates easily, right? This is what alcoholic KOH wala business was. Okay, so I took my reagent, going back here, saying strong base. What is a strong base? NaOET, okay, which is EtO minus basically. Okay, when this goes in solution, it forms Na plus and EtO minus. If I take this, then my solvent must be EtOH. So the solvent now depends on your reagent, which is very interesting. So sometimes you'll see ether and all of those other things as well. Cool. Leaving group ability, as always, is this guy. So to summarize, I know काफी theory heavy हो गई, इसलिए मैंने सारे सवाल शुरुआत में कर लिए of SN1. In the next session, we'll do more questions. Don't worry. Okay. एक दो सवाल अभी भी हैं, रुक जाओ. So this is regioselective, follow Sedgwick's rule, bimolecular, rate is proportional to this guy, and I've written OH minus, but I think strictly speaking, I should write base minus. Okay, rate is proportional to RX and base minus, B minus, which is the base itself. Alkyl halide reactivity, tertiary gradient, secondary gradient, primary. Strong base favors it, single step, high temperature, and transition state है जो हमारा thumbnail में है. That's and also on NCERT made very nicely. Couple of questions ले लें. Couple of questions. Hey Divakar, how are you doing? Which of the following is the most reactive towards alcoholic KOH? Try करो. Try करो. Try करो. Try करो. कुछ हम लोग हटा दें, eliminate कर दें. पहले A को हटा देते हैं. Right? Because that's not something we have done. हमने पढ़ा नहीं है. Triple bond नहीं बनेगा अभी. You be like, हाँ भाई triple bond बन सकता है alcoholic KOH से. Hold your horses. Maybe not. A को हटाते हैं. What about B, C and D? If you were to take a guess, educated guess, you may remove D and C because ये तो यार दोनों primary है. Or you remember, primary वाला तो यार doesn't seem very likely. Tertiary greater than secondary greater than primary. But yeah, tertiary कुछ तो है ही नहीं. Yeah, this is also primary. But here, this if it forms a double bond, in this case, let me draw this molecule. Hold on. It'll be better. It'll be a lot easier to understand if I draw this molecule out here. अगर ये बना, then there is conjugation that's possible, right? Because of this double bond here and oxygen K electrons, etc., another double bond over here. Hence, this final product is going to be quite stable. इसीलिए this is the most reactive. Okay? थोड़ा सा tricky सवाल है. That's why, oh, but great. Tanu, Dipanvita, Deepu and Mayuk. Lovely. All of you got this right. बहुत सही. Excellent. Amazing stuff. You students are so brilliant. खैर, I'll call it a day. थोड़ा theory भारी हो रहा है. I know. इसलिए मैं पहले सारे सवाल कर देता हूँ, फिर I'll leave the theory towards the end. I know teachers prefer to do the opposite thing. पहले सब पढ़ा देते हैं, फिर do questions. But I'm giving you a lot of time, right? When's my next session? आज क्या है? आज है Tuesday. Thursday, bro. Saturday. Yeah, you have a couple of days to revise this, and then we will do a lot of interesting questions on these ideas. You have a couple of, just one homework question, an interesting one, right on top of my head. एक ही सवाल है आज. Try it out, okay? And I'll see you tomorrow for kinetics. Attend that session, and then हम मिलते हैं उसके बाद Saturday को. Cool. The summary is very simple, short and sweet. हमने दो चीजें की इस सेशन में. SN1 reaction, which is जिसका schematic यहाँ पे है, और SN और E2 reaction जिसका schematic यहाँ पे. ठीक है? चलो. I will see you guys, and yeah, give me feedback if you want to change anything. If I'm speaking too fast, speaking too slow, covering too much, covering too little. I don't think I'm doing either of those. मैं तो NCERT, I'm sticking to NCERT. Maybe थोड़ा सा NCERT के ऊपर जा रहा हूँ sometimes. Give me feedback. Anything that you want me to do to make things better for you. Any different kind of sessions. Right now I'm doing theory sessions and one PYQ session in the week. अगर कुछ और करना है, बताओ. Yeah? All right? चलो. Have a great day. Yeah? Bye everybody. Dipanvita, Poonam, Manpreet, everybody else. Thank you. Thanks everybody. See you. Bye-bye.